between AB and BC. This point C will be moving towards A. So the distance AC will decrease. As you keep decreasing the angle, distance keeps on decreasing. And the minimum length comes when the angle is 0. Then what is this AC? It is AB minus BC. It is AB minus BC. Difference of other two sides. But can it be equal to difference of two sides? No. Because in this case also, when angle is 0 also, again we have three collinear points. We cannot draw this triangle. So angle must be at least something slightly greater than 0. So that you can join them and you can form a triangle. Like this. So difference of any two sides must be less than third side, which must be less than sum of any two sides. So whatever dimensions are following this principle, say they can form a triangle. And if they are not following this principle, say they cannot form a triangle. So employ this, take those dimensions and check whether they are following this principle or not. First 6, 6, 12. Take any side as the third side, it doesn't matter. Whether you are taking 6 or 12, it doesn't matter. Take any side as the third side. Let's say I am taking 12. It must be less than sum of other two sides. Must be greater than difference of other two sides. Which says 0 less than 12 less than 12. Now 12 is not less than 12 here. These are not following this principle. Third side cannot be equal to sum of other two sides. It must be less than that. So 6, 6, 12 are not following this principle, so we say they cannot form a triangle. Similarly, take 7, 3, 11. Now take any side as the third side, 7 or 3 or 11, it doesn't matter. Let's say I am taking 11. It must be less than sum of other two sides, must be greater than difference of other two sides. Which says 4 less than 11 less than 10. Now 11 is not less than 10. So these are also not following this principle. So he says 7, 3, 11 also cannot form a triangle. Next one, 5, 6, 10. You take any side as the third side. Let's say I am taking 10. It must be less than difference of other two sides. So less than sum of other two sides. And must be greater than difference of other two sides. Which says 1 less than 10 less than 11. Now this is true. So we say 5, 6, 10 can be the sides of a triangle. So whatever dimensions are following this principle, we say they can form a triangle. So here 5, 6, 10 can be the sides of a triangle. Next one. So there are two important triangles which you must be aware of here. One is a 30, 60, 90 triangle. A 30, 60, 90 triangle. And the other is 45, 45, 90 triangle. A 30, 60, 90 triangle and a 45, 45, 90 triangle. So we must know the ratio of sides in these two triangles. In a 30, 60, 90 triangle, sides are in the ratio 1 is to root 3 is to 2. In a 30, 60, 90 triangle, sides are in the ratio 1 is to root 3 is to 2, where 1 corresponds to the side opposite to 30 degrees. So if side opposite to 30 degrees is 1 unit, side opposite to 60 degrees is root 3 units, and hypotenuse is 2 units. If side opposite to 30 degrees is 1 unit, then opposite to 60 degrees it is root 3 units, and hypotenuse will be 2 units. Whereas in a 45, 45, 90 triangle, sides are in the ratio 1 is to root 2. In a 45, 45, 90 triangle, sides are in the ratio 1 is to 1 is to root 2. So when one side of the triangle is given, using this ratio of sides in these triangles, when one side is given, using this ratio, you can find out what are all the other sides, or what is area, or what is perimeter. Anything related to this triangle which he is asking. And also, if you look at how we are getting this, we get them using trigonometrical concepts. Sin 30, cos 30, sin 60, cos 60, tan 60, those values. But as far as our syllabus goes, we have nothing related to trigonometry. So no need to know those values. Just remembering this ratio is enough. So application of this in that next question, it is the application of this. Just use this ratio. In a 30, 60, 90 triangle, sides are in the ratio 1 is to root 3 is to 2. So if side opposite to 30 degrees is 1 unit, opposite to 60 degrees it is root 3 units, and hypotenuse is 2 units. But AC is given as 5. If it is 5, you have to find out what is AB and BC. So if side length is 5, you have to find out what is AB and BC. So one way is, you can take two sides at a time. Like AC is to BC is 2 is to 1. If AC is 5 units, what is BC? Like this. Using this ratio. Ratio is there. One of the value is also there. Find out the other values. Or else directly let us find out both the values at a time from this figure. According to the ratio, if AC is 2 units, then BC is 1 and AB is root 3. But according to the question, AC is not 5. Sorry, AC is not 2. It is given as 5 units. So if it is 5 units, then you have to find out what are the values here. So we have to make this 2 as 5. For that, you can either multiply or divide. Only by multiplying or dividing, you have to make this 2 as 5. Because multiplying all the terms in a ratio with a constant or dividing all the terms in a ratio with a constant will not affect this ratio. Multiplication or division of a constant to each and every term will not affect this ratio. So to make this 2 as 5, multiply 5 by 2. Whenever you are multiplying 5 by 2, multiply all the other sides also. So if AC is 5 units, now BC is 5 by 2 and AB is 5 root 3 by 2. So we get BC as 5 by 2 and AB as 5 root 3 by 2. So what I am doing, according to the ratio 1 is to root 3 is to 2, if AC is 2 units, we know what are the other sides. But we need to know what are the lengths if AC is 5 units. To make this 2 as 5, I am multiplying 5 by 2. Whenever you are multiplying a term, multiply all the other terms also.